Okay, they say question K. How do you resolve more than two vectors? And we have this diagram. So to resolve more than two vectors, let's say this is question K now, and this is the diagram we're given. All I need to do is, once I see any vector, they tell me this kind of question, they say resolve the coplanar forces. Once I see this question, all I just need to do, once I hear the name resolve, I go and do x, y, then come and put the forces. I have F1, I have F2, and I have F3. So now I will be doing, to resolve F1, this is an angle, there's an angle here. Even if the angle is here, I just come and do, everything here is 90, subtract that angle, you use this one. So carrying this to the x-axis, I'll get F1 cos theta. Carrying this to the y-axis, I get F1 sine theta. Then the same thing for here. Even if I have the angle to be here, I will say all the angles here should be 180. Yeah? That means from 90, add up the angle. Let's say they give me 40 here. I'll do 40 plus 90. That's 130, everything here. Then subtract the angle you have. That's 130. Because angles, everything here should make up to 180. Then I have 180 minus 130. Then I'll use this angle. Or maybe they gave me this angle. So what I'll just do is carrying this to this side, x-axis, I have F2 cos theta. Then F2 sine theta. The same thing here. Same thing here. Carrying this to x-axis. Let's say they give me an angle here. Let's say they give me an angle here. Let's say they give me an angle theta here. Let's say this theta is like 20 degrees. All I'll do is, every angle here should be equal to 360. So I'll do round 360. Then I'll do 0 to 90, 90 to 180, 180 to 270. Then 270 to 360. But notice that this is 360. Then that is the same thing as saying 270 plus what I have here gives me 290. Shebi, it gives me 290. So what I just need to do is to say 360 minus this is 360. Shebi, 360 minus 290. That is 270, 280, 290. So I do 360. Everything around gives me 360. Then when I do 270 from this point to this point, 270 plus this 290. Then to get to this, I do 360 minus 290. So if I remove it should be 70. So I get 70. So the angle I will use is this angle, which is 70. So if I'm going to use 70, I will now do, taking this to x-axis, it becomes F3 cos 70. So let's just use theta. Then taking this to the y-axis, I use F3 sine 70. But remember, it's theta, we use 3 sine theta. So by the time you finish doing this, you sum it up. So the sum of F1, F2, F3, that's what you get here. And that is, by the time you do this now, the sum of F1 cos theta plus F2 cos theta plus F3 cos theta. So by the time you sum it up, you come and do for y F1 sin theta plus F2 sin theta plus F3 sin theta. By the time you finish doing it, to find the resultant now, you have created everything here to be on the x-axis. F1 plus F2 plus F3 with the cos thetas. Then for y, F1 plus F2 plus F3. And you've done the cos thetas. So by the time you finish doing it, now using Pythagoras, you get the resultant, the r. So you do r square equals to y square plus x squared. So to get r will simply be square root of y squared plus x squared. So you get r. Very simple. Alright. That's how you get the resultant. And whenever you get a resultant using Pythagoras, to get theta, you simply do tan theta equals to y over x. So theta will be equals to tan inverse of y over x. Very simple. Alright. So I said here, find the resultant. Remember, I've taught you in projectile. Check my class on projectile to see why y is always sine theta and why you always do x with cos theta. Check my video. So where I taught you something like this. Now if I have this, something of this nature, that's, let's say this is y, this is x, and this is r, then you need to remember so ka tua. That is sine theta, opposite over hypotenuse, sine theta, oppo over hypo, cos theta, C stands for cos theta, adjacent over hypo, C stands for tan theta, opposite over adjacent. So if you do this very well, notice that there's an angle here. So if you do this way, what is the opposite side here? Or should I say, what's the hypotenuse? R. Then, what's the opposite side here? Y. What's the adjacent side? X. So sin theta will simply be the same thing as saying y over r. So remember that if I have this kind of angle, for example, and I have this theta, the opposite side is here. This is hypo, this is adjacent. So notice this. So in 90 degrees, we always imagine it this way, this opposite, adjacent, hypo. In as much as you know that yes, we normally put this thing we are putting is to show you that yes, the angle is at horizontal, vertical. So we know this. So if I know that y, so making y subject of the form, you see that y is equals to r sine theta. Then for cos now, for cos theta, so that this is adjacent is x over r is hypo. Making x subject of the formula, you have x equals to r cos theta. Then tan theta will be equals to tan 2 opposite over adjacent. So that is why anytime we are doing anything, to find the direction we use this. Then to find x we use this. To find y we use this. So the only time we normally come and replace y with sin theta or x with cos theta when we are doing tan theta is maybe in advanced trigonometry or classes like that, things like projectile motion. But for finding direction of a vector, keep it this simple. Why? That is the sides. So let's move to the next question. They say find the resultant of the system of vectors shown below. Find the resultant of the system of vectors shown below. So see, I have, so once I see this, to find the result, what I just need to do is to go and draw the x and y. This is question L. Question L. So I just go and draw x axis, draw y axis. Then if I do this, notice that they gave me, I always start from this side, x axis. They gave me there's a force acting this way and it's 4. They did not give the units, but let's say I choose to call it force 4 Newton, 6 Newton, and 2 root 2 Newton. So I have 4 Newton, 6 Newton, 2 root 2 Newton. They did not give me unit, but I'm the one calling it force. because whenever it's acting at such an angle, normally consider it coplanar forces. So notice that 2 root 2 is at 45 degrees, but this one is at horizontal axis, this one is at vertical axis. So it's happening at y6, not when it's happening at y6. There's nothing for, so this thing can be drawn the same way as saying I have something of this nature, 6 and x 0. Then I also have when this is 0 and x is 4. Then I now have 2 root 2. This one is happening at the same time. So for that reason, I'll have the 4 is at x 4 0, then 6 0. So for 2 root 2, notice this is 45 degrees. Let me redraw that. Let me redraw this part. This 2 root 2 is the same thing as saying I have this, 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 then I have 45 degrees here. And notice this is the third quadrant where we have 270. So I'll simply say angles from here to here. First quadrant is 90, second quadrant is 180, 180. Third quadrant, everything is 270. So I just do 270 minus 45. So if I remove 45, if I remove 45 from 270, you see that I'm going to have 35. I say 35 because if I have, so that means if I have this everything here to be 270, everything here, then I minus 45, which means that the angle from this point down to here is 225 degrees. 225 degrees plus this 45 gives me 270, which is this quadrant. So I told you, if I want to use this 45 degrees to solve, okay, we've solved using when we are always having to subtract. Let's try to use this 45 now to see what I mean. So I know that I can use the 225. That's the method we've been using. Then I will now be doing, since I have the 225, I say taking this to x. Taking this to x now, you see that I'm going to be closing the angle. That is, I'm going towards the angle. But taking this away from the angle, taking this to y, I'm going away from the angle. I'm using ASTC. Away from the angle, use sine. Towards the angle, use cosine. Once you're able to subtract the angle given from the quadrant that it falls under, you will be correct to use ASTC. But in this case, if I don't want to subtract the angle from the quadrant and I want to just use what I'm given, let's do it now. So I will say this is third quadrant. In the third quadrant, y is minus, x is minus, minus, minus. So I just come here. I come down to x and put minus, come down to y and put minus. Then I go back. Then if I go back, I'll say, carrying this now, this angle 45 now, this angle 45, trying to take it to y-axis. Notice that I'll be closing this angle. So it's going towards, and it's reverse of what we used to do. So towards y, towards the angle now is giving me y, which is cos. So I will do 2 root 2 cos 45 degrees. Now, let's say I'm trying to take this now to y-axis, to x-axis. Notice that as I'm going to to x-axis, this angle will be opening, it will be expanding. So I'm going away from the angle to x-axis, which is not usually the case. Assuming I used 225, I will obey it, but whatever you do will still give you the same answer. So that's why I'm using this style now. Going away from the angle now, I'm going towards x in this case. So I now have 2 root 2, and away from the angle is sine 45 degrees. So if I do this, let's punch. Let's see what we will get from that. So we get sine 45 and cos 45, they are the same thing. Yes, and I know that sine 45 is root 2 over 2. Shebi, let's punch 2 sine 45 Wait, let's do this way. I get, yes, I get 2, yes, so it's going to be root 2 over 2. So we have 2, we have 2 root 2 cos 45. We get 2 root 2 cos 45. We get 2. And notice that we also have minus here. So minus 2. Then let's do 2 root 2 sine 45. It should give us the same thing. We get 2, but notice that there's minus here. You see it? Which means that if you still come, let's say we used towards the angle, going towards the angle, and we used sine, that is, we used 2 root 2. In this case, let's say we are going like this now, using this 2 to 5. Going towards is going to be cos. So you see that it will still give you the same answer, but the only thing is that 225 now will be positive, will be negative. So let's do 2 root 2. Let's do 2 root 2. 2. Let's do 2. Let's do this one. 2. Sorry. 2 root 2 cos 225. Sorry, here you go. 2 root 2. So let's do 2 root 2 cos 225. So you see, it will give you minus 2. It will give you minus 2. Cos. So that should give you minus 2. I don't know if you can see it well. Minus 2. Yes. So we are correct. So that means we are correct. So let's now add up. Let's now get the sum of x and y. So that we have 4 minus 2 is 2. Then we have 6 minus 2, 4. So you see it. So that means that we've succeeded in resolving everything here to x and y axis. So everything, we've taken this to x and y axis. This is in x, this is in y, this is in x. So we now have everything about that force to be this way. 2 and 4 should be yes. So to get the resultant now, using Pythagoras, r, so we now have r square equals to 2 square plus 4 square. This is something I'm saying 4 plus 16. R square is equals to, so r is equals to root 20. So let's punch. Root 20 is equals to, r is equals to 4.4721, approximately 4.5. And remember, we chose to use Newton. You can use even meter, any units, so far as it's not given. But assuming it's given, we maintain the one given to us. So let's say we are asked to find direction. Let's say we want to find direction for this now. If we want to find the direction, we will now have that this will be tan theta. I've told you, once you use Pythagoras, just use tan theta to find you direction, the angle. And notice that here is positive, here is positive. So whatever we get for this direction should be in the first quadrant. That means maybe here is minus. Whatever we get, after getting, we'll go and check the quadrant that has y to be minus and x to be plus, and vice versa. That is depending on the case. So let's say I now get y over x. And notice that y here is 4 and x is 2. So, and this is the same thing as saying 2. So tan theta is equals to 2. So theta is equals to tan inverse of 2. So let's see what we have. So for tan inverse of 2, we have theta to be equals to 63.4 degrees. So you see it. So this is in the first quadrant. But assuming maybe y is minus, maybe we have x to be 2 and then y minus 4. The minute I finish and I get this 63.4, I will go and check. First quadrant, I have plus plus. Second quadrant, I have y to be plus, x to be minus. Then it's in the third quadrant that I have x to be plus and y to be minus. And third quadrant is 360. I'll simply do 360 minus 63.4 degrees. Whatever it gives me, let's say 360 minus 63.4. If it gives me 296.6 degrees, that will be my direction. Remember, I'm never going to have a negative answer. That means before I even come to do this, if I do that, I'm supposed to have like -2 here first of all. So if I do that, I will ignore the negative. Then when I finish, I now come and do this. So assuming I did this now, -4/2, it will give me -2. I will ignore the minus. I will always ignore the minus, but when I finish, I will go and subtract it. It's telling me the quadrant that it falls into. So I believe as we progress, we'll see examples like that. So let's move to the next question. The next one says, we've done something like this. It says a vector, find the magnitude. So this is your assignment. I want to quickly move to vector product. All you just need to do is to say, notice that we've done this. This is 50. Angles on a straight line, 180. Everything here should be 180. So I do 180 minus this 50, 130 degrees. So this is the angle I will be using. Angles on a straight line. So this is the angle I'll use. So if I'm carrying it out, I carry it out the way I've been carrying the others. So we'll solve the question. So let's check. They said vector times vector. Let's think about it. I know that a perfect example of vector is force and displacement. So force times displacement is work done, and work done is a scalar. So this is scalar. So now vector times scalar. Let's check. I have force times distance, which gives me moment, and is a vector quantity. So I have vector over scalar. Yeah? So let's use velocity over time, Shebi, or displacement over time. Displacement is vector, time is scalar, and that gives me vector, because displacement over time is velocity, which is vector, and velocity over time is acceleration, which is vector. So that is what I have. Let's move to dot product and vector cross product. So they said explain dot products and cross products. So first, I'll simply need to remember that multiplication of vectors Multiplication of vectors can be done in two ways: dot product and cross product. I will say that another name for dot product is scalar product, and another name for cross product is vector product. And we normally give this dot product by A dot B. We normally say that A dot B is equals to magnitude of A, then magnitude of B cos theta. And then Y cross product is given by A cross B is equals to magnitude of A, magnitude of B sine theta. Sine theta. So this is how we normally give it. Then you need to know that what we call a unit vector, let's say, which is represented with A caret or A like this, we normally say that is equals to the vector all over the magnitude. So this is A vector. Unit vector of A is this. But there's something we call I, J, K vectors. And these I, J, K vectors, we call it unit vectors because it represents 1. They all stand to mean 1. What they just show is that this one is in x-axis, this one is in y-axis, this is in z-axis. More like I, J, K. So if we know this, so when we are multiplying, let's say vector AI times vector AI, using dot products, when we want to do dot, we don't use times again. Rather, we do AI dot AI. And I dot I, these two units, when they times each other, it becomes 1. Then now A times A can be A square. Very important to note. And 1 times A square is the same thing as A square. So for dot products, I and I dot I is equals to 1. J dot J is equals to 1. K dot K is equals to 1. But that is not the same case with cross products, because cross product simply means if I have J, and I have K, is crossing. So I cross I cannot happen, is 0. Then J cross J cannot happen. You cannot cross J. It's impossible to cross J here. Like to use I and cross I here is not possible. So you crossing it is impossible. Same thing with K cross K is impossible. So but what we have is that I can cross to J, J can cross to K, K can cross to I. When I cross to J, when I cross J, like if I cross J or the gafere J, if I cross J, the next thing I'll get me table K equals K. Now, if J cross K, once J come and cross this K, the next thing is meeting is I or J. Then if Shebi, yes, J cross K. Now if K cross I is meeting J, K cross I is meeting J. This is how you need to visualize this. But a situation where it goes in the other direction, let's say I have I, J, K. And instead of moving in this clockwise direction, it moves anti-clockwise. Notice that if now I use I and cross K, it will give me J, but in the negative direction. So I cross J, that is anti-clockwise. When it's anti-clockwise, this one is clockwise. So anti-clockwise, it will give me negative K. Then I cross, see, I, notice it, I cross K to give me J. So then J cross K. And notice that in this case, it is no longer going to be going this way. Rather, it's something of this nature. Instead of I cross J, now it will now be J cross I. So J now cross I to give me negative K. So it's moving in negative direction. Now, Then K cross J. So K now, J cross I gives me K. K cross J give me negative I. Then K shebi, yes, K, see it, K cross J, it gives me negative I. Then I cross K gives me negative J. So I, see that this one can be one kind, cross K gives me negative J. Very important to note the clockwise direction and anti-clockwise direction. So if I know this, it simply means that I cannot have this to happen. That is why every vector or cross product always comes back with the I, comes back with the J, comes back with the K, because the I's don't cross. So, and we normally use matrix or determinants to find this. We'll see all those kind of questions, but just understand this now. That's the difference between cross product and dot product. So let's look at a question here. Question Q. They said the magnitude of the components of a vector C along x and y are 8.7 and 5. Calculate the magnitude and direction of the vector C. Let's just write it out. When a question is given, it might be hard to understand, but just leave the English, do the interpretation, see what you have. The magnitude of the components, and you know what magnitude means. So this is the sentence saying I have a vector C. I have a vector C. Its magnitude in the x direction is equals to 8.7, and its magnitude in the y direction is equals to, you say its value. I told you another name for magnitude is value, size. That's why in mathematics you see absolute value, they represent it with this. Let's say it's 5. Okay, then I say calculate the magnitude and direction of vector C. And she calculates this vector C, the magnitude. And when they say we should calculate the magnitude, that is the total magnitude, is the sentence as saying add up x and y, which is the sentence adding up vector is what we call resultant. So when we see this kind of case, this thing that we are doing here is just for us to be able to interpret it. But in physics, we don't do this kind of thing. Once we see it, we just do y side, x side. So in the x side, we have 8.7. In the y side, we have 5. They're now asking us to find the resultant and then the direction. Very simple. Very simple question. That's what they're asking us. So one thing about this is for you to understand how to interpret this question, and then when you understand how you interpret it, you now know how to be solving it. So they say magnitude. If they say magnitude, that magnitude should not confuse you. Just come and write it out. Only for x, only for y. That is the value of x, the value of y. Then what we really call magnitude is when you've summed up the resultants. So this is simply using Pythagoras. I'll do r is equals to square root of, using Pythagoras, 5 square plus 8.7 square. R is equals to, let's do it. R is equals to 10.03. That's my resultant. So to find the direction is simply tan theta is equals to y over x. And this is something that's saying tan theta is equals to 5 over 8.7. Theta is equals to tan inverse of 5 over 8.7. So what do you get? Let's do it. 5 divided by 8.7. We have 0.5747. So tan inverse of this so let's do it. 0.5747. So theta is equals to 29.9 degrees. So this is my answer, and this is going to be the direction. Reason being that the x and y given to me are all positive. It's in the first quadrant. So if I want to even do it, since it's in the first quadrant, if I really want to get the direction, I can say first quadrant is 90. I can do theta equals to 90 minus 29.9. That is in case you look at the option and this is not there. But in most cases, this is your direction. This is your direction. But maybe they did taking this to be that is somewhere around that quadrant. So you can do 90 minus 29.9. So theta is equals to 60.1. These two, they are correct. This is much more correct, but this is in case you look there and you did not see it, so you show that it's in the first quadrant. That's showing that it's in the first quadrant. This is correct. So this is your angle. This is your angle. This is your direction. All right. So, and this can also be your direction. For some of you are good at quoting. Oh yeah. Now let's move to the next one. They said add AXI plus AYJ plus AZK and B equals to BXI plus BYJ and BZK, that we should add it. So for me to add this, I'll simply do, to add it is going to be the same thing as saying bring out vector A. This is even wrong. You don't represent vector with small letter. This should be A, this should be B. So vector A should be equals to AXI plus AYJ plus AZK, and vector B is equals to BXI plus BYJ plus BZK. So what this thing is going to mean is simply carry everything here, carry everything here together, carry everything here together, carry everything here together, carry everything here. So vector A plus vector B. In most cases, you see an arrow, So this vector is going to the same thing, is showing direction. It's going to the same thing as saying A plus B I. And we know that everything I means X. And so we can say AI plus BI X plus AJ plus BJ Y, then plus AK plus BK Z. Simple. Now they said simple. So let's go to the next one. They say find the dot product. Find the dot product of what we have here. AXBX plus AYBY plus AZBZ. Wonderful. If I'm to find this, it's going to be the same thing as saying, let's do it this way. So if I'm to find this, it's going to be the same thing as saying to find the dot product will be, let me write it out first. This should be A dot B. We don't represent vector with small letter. So S A dot B. They said there is equals to, let me write it, AX BX plus AYBY plus AZBZ. This is going to be the sentence saying bring A here, okay. But if you look at this very well, this is everything here is happening at I, plus everything here AYBY is happening at J, plus AZBZ is happening at K. Are you kidding me? Yes. So if I'm to find the dot product, what exactly? I've been able to take, now that I've done this, I've been able to take it to the I axis, J axis, and the K axis. What I will now do is to simply find, remember that A dot B is always equals to magnitude of A, magnitude of B, then cos theta. Yes. So I will now have that this is going to be the sentence saying get the magnitude of A. And magnitude of A is the sentence saying square root of everything AX plus AY plus AZ all raised to power 2. This is magnitude of A. While magnitude of B is the sentence saying square root of BX square plus BY square plus BZ square. So by the time I get this, I come and multiply the two. So notice that if I do this now, I'm going to have a situation whereby I get value for this, then multiply the two, then cos theta, the cos theta, whatever it gives me is equals to A dot B. So that will be it. So by the time I do this now, A dot B will now be equals to whatever I get here, whatever I get for square root of AX square plus AY square plus AZ square, then multiplied by square root of BX square plus BY square plus BZ square. And whatever I get here, then if I times it now times cos theta, that is what you get as your dot product of AB. Alright, let's move to a perfect example so you understand this. As they said, you should get A cross B. IJK, we are given this. Then solve A cross B cross C. Wonderful. So to solve this, let's use this to get an understanding of what it is. So it's simply going to be A cross B I J K. Once I write this, I normally come on my own, I'll put plus, then put minus here. Now, I have AX, I have BX. Remember the one we are solving is this one. Then I have AY, I have BY, I have BZ, I have AZ, sorry. Then I have BZ. What this thing entails is that when I'm solving for Y, when I'm solving for I to find the cross product, I normally, what I will do is to simply come here. All these things that are beginning, I will come and do I will have its own box. Then I'll come and put, remember this plus J will have its own box. Then remember this minus K will have its own box. So when I'm solving for I will not look at I'll focus on the things here. So that I will now do by the left mark time. left, right. So I will now do A times BZ, AY times BZ, then from minus left, left from right minus AZ times BY. Then when I'm doing for J, I will ignore everything about J, then focus on these two. So when I'm doing for I, simply the same thing as saying when I'm doing I, you cross I and go to J and K. When I'm doing I do J, I multiply J and K left and right. Then when I'm doing for J, let's rewrite this: I, J, K, AX, BX, AY, BZ, BY, AZ, BZ, H. So when I'm doing for Y, I will overlook this. Remember, it's cross product. I cross it, then go to the next ones and cross. So when I'm doing for J, I ignore it. I just do I cross K. So, and I'll do I cross K using left, right. So now, using left, right, by the left, mark time, left, no, yes, left, this is my left. So, I left, mark time, left, right, left, right. So, AX, BZ, you ignore the J, multiply I and K, then minus from the right, AX, sorry, the right, AZ, BX. Now when you are doing for K, let me write it again. You ignore K. So it's more like, let me just write it for K. You ignore everything on K. Focus on AX, AY, BX, BY. But let me just write this. So for K, ignore this. You use I and J. So remember that I cross J gives you K. I cross J gives you K. So you ignore it. And I cross, watch, look at it. Are you kidding me? What am I saying? Let's do I cross, where is that thing? I cross J gives you K, yes, and J cross K gives you I. So see, J cross K, when we did J and K, J cross K is for I, we are solving. It gives you I. J cross K gives you I. So you see that the value we have for I is from J cross K. Then when we did I cross J, see that it gives you for K. So I cross J gives me K. So to solve for K, to get for K, we'll cross I and J. So left, right, AX, BY, from minus right, left, left, right, left. This is your left, starting from up, down. Then this is your right, down. So AY, BX. If you like, insist your left is your right. So see it, I have my, this is left side, right side, left, down, right. So once I've gotten this, whatever answer this gives me, if you see, you add it up, you subtract, it will carry I, subtract, it will carry J, subtract, it will carry K. Then when you finish, you now have it with whatever you have here, I plus whatever you have here, J, minus whatever you have here, K. That is your answer. This is your answer. So let's use a perfect illustration. Over here we have we have if B equals to 7I minus 3J plus 2K and Q equals to 4I plus 5J minus 7K, find the magnitude of P and Q. Then B, I, scalar product of PQ. Then cosine angle between P and Q. So let's say I have P. So if you remember that time we normally do resultant R square. We normally say is R square equals to R. We normally say R at the end of the day. We say R square equals to A square plus B square, for example. Then after everything, we say R is equals to square root of A square plus B square. If you remember, R is always equals to this. And I told you another name for this R is resultant. Another name for this resultant is magnitude. So whenever you are doing the magnitude of for vectors ij or ijk, just know it that the magnitude, which is in this case for P or for R, is going to be the same thing as saying I square plus J square plus K square. That's the magnitude. If it's just I and J, to be I square plus J square, take the square root. That is how you find magnitude. And it's coming from this whole idea. Of resultant. I told you another name for resultant is magnitude. So for this Q and P now, that we have to find the magnitude, all I just need to do is to say magnitude P, and I told you we use this symbol, is equals to, ignore the I square, just put square plus, even if I put minus 3 and square, it is going to still be plus, plus 2 square. This is going to give you 49 plus 9 plus 4. Then carry one, put here 50. 59, 62. So remember that it's going to carry the square roots. So square root of 62. Let's punch. So this is going to give me P to be equals to 7.9. Then for Q, for magnitude of Q, this is going to be the same thing as saying square root of 4 square plus 5 square plus minus 3 square. This is going to give me square root of 16 plus 25 plus 9. So this will give me square root of 50. So, and square root of 50 is the same thing as 70, Jesus, 7.07, approximately 7.1. So now that I have this, remember the question said find the scalar product, and another name for scalar product is dot product. They say find the scalar product. Another name for scalar product is dot product. So to find the scalar product, I'll remember that A dot B is the same thing as saying A magnitude, B magnitude cos theta. And A dot B itself is equals to 7I dot 4I. Then between them I have minus 3j dot 5j plus 2k dot minus 3k. Or yes. So when I have this, I always put the I and I put the k and k, because the dot product is like that. So notice it. I will do anything I will dot it. Anything j, I dot it. Anything k, I dot it. So I can even do it from here. So I will do 4 times 7 is around 28. But this time around with the I dot I is going to be 1. So 7 times 4. So see that even here, if I do it here, I'll get 28. I dot I is 1 plus. Now see, 3 times 5 is 15, but it's carrying minus j dot j is 1. So it will be minus 15. Then 2 times minus 6 is 2 times 3. 2 times minus 3 is minus 6. K times k is 1. And 1 times 6 is this. So I have this to give me 28 minus 15 minus 6. So A dot B is going to be the same thing as saying 28 minus 15 minus 6, which is the same thing as saying 7. So A dot B. Okay, another mistake I'm making is putting this to be in magnitude. I'm not supposed to be putting this in magnitude sign. I'm not supposed to be putting this, because this is magnitude of A dot B. So it's just A dot B. So A dot B. So note all these things I'm teaching you. Note all these things that I'm saying. Very important. So we've gotten B, then gotten the B magnitude. Then we've gotten A dot B. And anytime they ask you to find the angle between the two vectors, like find the angle between this P and Q, is always easier to use dot product than to use cross product. Notice that if it's cross product, by the time you start doing determinant and the rest, it takes more time. That's why in most textbooks you just see them do the dot product and get an angle from it. So to get the cosine angle, the question said cosine of the angle between P and Q. To get the cosine angle, I will now say, remember that A dot B is equals to A magnitude B magnitude cos theta, and A magnitude and here what we are doing is not A and B, but rather P and Q. You see it? All these things you might think is mistake. It's not really mistake. It's of advantage for you to be learning. So it's not A and B we are supposed to use, but P and Q, because that's what we are given. P dot Q. So this is P dot Q. So when you remember that Sarah even made mistake that day, it sinks. So now I will do P. Okay, P dot Q. Since P dot Q is equals to P magnitude Q magnitude cos theta. To make cos theta subject of the formula here, we'll simply have cos theta is equals to, divide both sides by the coefficient of cos theta, which is magnitude of P, magnitude of Q. So you now have, I'm trying to be fast. You now have P dot Q all over P magnitude Q magnitude. So theta will be equals to cos inverse of P dot Q all over P magnitude Q magnitude. So substitute this is a bracket I'm trying to create here. So substitute the values of P dot Q and magnitude P and Q, you get your answer. Well, let's do it. So I'll have theta is equals to cos inverse of P dot Q, we got it to be 7 all over. Then magnitude P, we got it to be 7.9. And magnitude Q, we got it to be 7.1. So by the time you multiply this out and divide, you get an answer. So let's do 7.9 times 7.1. We get 7 all over 56.09. Then cos inverse of it. Theta is equals to cos inverse, first of all, 7 divided by 56.09. Okay, 7 divided by 56.09, you will get cos inverse of 0.1248. So let's do the cos inverse of this. Cos inverse 0.1248. So that's giving me 82.83. So theta is equals to, and this is theta, approximately 83 degrees. So this is my final answer. So it's easy to use scalar product to find the angle between cosine than it is to do cross products. So I get this as my answer. Alright, let's now try to solve the next question. Let's try to solve the next question. Next question says, okay, and this is where we'll stop. This should be the last question for today. They said if D equals to minus 5I plus 6J minus 3K and E equals to 7I plus 8J plus 4K, calculate D cross E. Find the angle between D and E. Show that D cross E is perpendicular to both D and E.